In a stunning revelation, the James Webb Space Telescope has detected something so extraordinary, it has sent shockwaves through the scientific community. Initially, the telescope focused on K218b, an exoplanet orbiting a cool dwarf star about 120 light-years away in the constellation Leo. While K218b had already piqued the interest of astronomers due to its location within the habitable zone, the region around a star where liquid water could exist, what the telescope found was beyond anyone's expectations. The telescope's powerful infrared sensors picked up evidence suggesting that K218b might be more than just a candidate for habitability. It might be a world with life-supporting conditions, or perhaps something entirely new, a Hycean world. Hycean planets are a newly theorized class of exoplanets characterized by vast oceans beneath hydrogen-rich atmospheres. These planets are generally larger than Earth, but smaller than Neptune, and have conditions that might support microbial or even more complex life. K218b's atmospheric composition included carbon dioxide, methane, and even dimethyl sulfide, a molecule that, on Earth, is almost exclusively produced by phytoplankton. The presence of this molecule caused a stir among scientists. If it truly exists in the quantities Webb detected, it would be one of the most compelling biosignatures ever found beyond our solar system. The implications of such a discovery are staggering. If K218b is indeed a Hycean world teeming with microbial life beneath a thick, hazy atmosphere, then our view of habitability in the universe must be drastically widened. It would mean that life might not only thrive on Earth like rocky planets, but also on planets that look nothing like our own. These findings open up a whole new category of celestial bodies where life might emerge. The scientists behind the discovery have emphasized the need for further observation. While the signs are promising, confirmation requires more data, more time, and more exploration. Still, the potential is enough to energize the entire field of astrobiology. But the James Webb Space Telescope wasn't done there. As researchers processed the stream of data coming from its instruments, something even more bizarre emerged. A massive black hole, not sitting quietly at the center of a galaxy as expected, but instead hurtling through space. This supermassive black hole was seen moving at a speed of 4 million miles per hour, and it appeared to be leaving a trail of newborn stars in its wake. The idea of a supermassive black hole on the move challenges our understanding of galactic dynamics. How could something so heavy, millions or even billions of times the mass of our Sun, be flung out of its galaxy? One leading theory is that this black hole was part of a galactic merger. When two galaxies collide, their central black holes spiral toward each other, eventually merging into a single, even more massive object. If a third black hole enters the scene, perhaps from a smaller colliding galaxy, it could gravitationally slingshot one of the original black holes out of the system. This ejected black hole, still dragging along stars and gas from its original galaxy, becomes a rogue object wandering the cosmos. That trail of stars left behind may be the clearest sign of its passage, a celestial breadcrumb trail marking the escape route of an enormous force of nature. To see such an event in real time, or at least catch its remnants as they appear today, is a marvel. It challenges the way we think about the structure of galaxies. If these runaway black holes are more common than we thought, then the centers of many galaxies could be missing their expected gravitational anchors. This would reshape how galaxies evolve, how they grow, and how the matter within them interacts over billions of years. The detection of this black hole, combined with the chemical signatures from K218b, has left astronomers in a state of awe. They now realize that our universe is far stranger and more dynamic than previously believed. The fact that such groundbreaking discoveries are happening almost simultaneously speaks to the power of modern technology and the capabilities of the James Webb Space Telescope. Designed primarily to observe the oldest light in the universe, Webb is also revealing how active, volatile, and richly diverse the cosmos truly is. Behind the scenes, the analysis of this data involves hundreds of scientists working around the clock. Advanced algorithms sift through terabytes of information, filtering out noise, interpreting spectral data, and confirming anomalies. For K218b, scientists focused on absorption lines in the planet's atmosphere. When starlight passes through a planet's atmosphere, certain wavelengths are absorbed by the chemicals present. These patterns can be read like a barcode, revealing the presence of specific molecules. In the case of K218b, those lines told a story of methane, carbon dioxide, and possibly dimethyl sulfide. Meanwhile, astronomers observing the speeding black hole used gravitational lensing and the displacement of surrounding stars to confirm its movement. Light bending around massive objects can reveal not just presence, but also velocity and trajectory. The Webb telescope, with its sensitivity to infrared wavelengths, can pierce through dust clouds that obscure visible light telescopes, offering an unobstructed view of these dramatic cosmic events. It's as though a foggy window was wiped clean, revealing the chaos and beauty of the universe in all its majesty. What does this mean for the search for extraterrestrial life? For decades, scientists have debated what signs of life would look like on other planets. Oxygen, water vapor, and methane have long been considered the Big Three biosignatures. But life could take forms we haven't yet imagined, especially on Hycean worlds. The detection of dimethyl sulfide suggests that we must broaden our toolkit for life detection. We need to consider new chemical markers, new atmospheric compositions, and new planetary conditions where biology might gain a foothold. The runaway black hole adds a different kind of mystery. Its presence implies that violent, high-energy events may be more common in the universe than we once thought. If black holes can be ejected from galaxies, it's possible that entire regions of space are shaped by these exiled titans. They may roam the void, consuming interstellar gas, warping spacetime, and influencing star formation even in isolation. These events also serve as a reminder of our cosmic fragility. A black hole passing near our solar system, however unlikely, would have devastating consequences. While none are currently known to pose a threat, the knowledge that such objects exist, and move at such incredible speeds, makes our position in the universe feel all the more precarious. As Wave's discovery continues to explore these profound developments, one truth becomes clear. The universe is far more complex, strange, and unpredictable than we ever imagined. The James Webb Space Telescope, still early in its operational life, has already rewritten parts of the cosmic story. From oceans on distant exoplanets to black holes tearing through galaxies, each discovery builds a richer tapestry of what exists beyond our tiny planet. And this is just the beginning. More targets await Webb's gaze: other exoplanets, early galaxies, potential supernova remnants, and even faint signals from the edge of time. Each new discovery not only answers old questions but raises new ones, pushing the frontier of science ever outward. We stand at the edge of a cosmic renaissance, fueled by instruments like Webb and guided by the questions we dare to ask. Whether we are alone in the universe or one of many life-bearing civilizations, one thing is certain: the quest to understand the cosmos will never lose its wonder. Every glimpse we get brings us closer to the ultimate question: what is our place in the universe? And as we learn more, we realize that the answers may lie not in familiar places, but in the most unexpected corners of the universe.